Fusion energy, to coin a term, appears to be just around the corner, as does James Webb Space Telescope. However, after much anticipation and waiting, it appears like the wait is almost over, and the telescope will launch this year. Fingers crossed for a successful launch, but it's worth mentioning that the launch system that'll carry the telescope into space is one of the most reliable. So, what will the telescope accomplish once it reaches space? Hey guys, hello and welcome back to Informatica. In this video, we'll talk about how the James Webb Telescope will make terrifying discoveries. First, make sure you subscribe to our channel and click the bell so you don't miss any of our videos. So let's get started. To that end, here are 10 riddles that the James Webb Space Telescope may be able to solve. 10th, planet formation. One of the more enigmatic aspects of planetary science is the process through which planets develop in the first place. The dynamics of the collapse of protoplanetary disk into a planetary system is a complex process with many unknowns. Because of all the dust and gas that creates those disks, it's difficult to analyze at optical wavelengths. James Webb comes in handy here. On the other hand, JWST is an infrared telescope that can conduct high-resolution investigations of these disks and maybe spot planets developing or crashing. It's a good idea to clarify how JWST operates and why it isn't an optical wavelength telescope like Hubble. The universe is teeming with infrared-emitting objects, but infrared astronomy is difficult to conduct on Earth's surface due to the atmosphere, which may block infrared while still emitting it as heat and causing interference. As a result, this type of astronomy is best performed in space. We've previously had infrared capacity in space, but not with the resolution of JWST. Infrared allows for the investigation of objects that are hidden by gas and dust and visible light. In the case of planet formation, this not only sheds information on how planets originate, but also how Earth-like planets form. Was there something about the Earth's genesis that encouraged the eventual existence of life? Is this an unusual or common occurrence? JWST could aid in the resolution of these puzzles. Number 9. Where does the universe get its material? You'd think that anything as massive as the Big Bang would have produced more than 4 sorts of atoms. However, the process by which the Big Bang occurred permitted it to produce only a large amount of hydrogen and helium, as well as trace amounts of lithium and beryllium. Everything else is the product of atoms fusing in the centers of stars. The heavier elements are created when these stars explode as supernovas or when neutron stars collide to become kilonovas. That took some time. As a result, JWST may investigate how this process occurs in a variety of ways. One way is through analyzing the dust in the interstellar medium, which may not sound particularly exciting, but it's the product of supernovas, which can teach us how massive stars populate the universe with their heavier atoms. We're ultimately made up of those atoms. The majority of what we're made of is supernova ash. The earliest black holes, number 8. With JWST, we'll be able to throw light on quasars and match them up with host galaxies. A quasar is a very bright active galactic nucleus that's fueled by a supermassive black hole that formed early in the universe's history. This is an area of research that's already revealing mysterious anomalies, such as the fact that at least one supermassive black hole in a quasar is much more massive than models suggest. Keep in mind that quasars are extremely distant objects, and the light from them has taken much of the universe's age to reach us, so when we study them, we're actually looking at a stage of the early cosmos. So these are pictures of the early universe that allow us to see if anything has altered and how things were back then. It'll be one thing if the supermassive black hole issue turns out to be a fluke or extremely unusual. Number 7. Galaxies and their evolution. Galaxies evolve. They can accomplish this in a variety of ways. One way is through mergers, which occur when galaxies collide and absorb one another, frequently significantly altering their prior structure. They can also just collide and pass by, creating gravitational effects. Even without that, the galaxies we see today, ranging from spirals to ellipticals, were formed in this manner for varied shapes. JWST will look back in time to the earliest galaxies to try to understand that fundamental evolution and how it works to produce the galaxies we see today. Another reason this is of great interest is that it would teach us how matter itself organizes on an enormous scale, which could lead to a better understanding of even larger structures such as voids. Number 6. The Proxima b problem. There is a planet in orbit of the nearest star to the Sun, Proxima Centauri, which stands out among the thousands of exoplanet discoveries made. And it's circling within the red dwarf's habitable zone, and it's just slightly more massive than Earth, estimated to be roughly 1.2 times Earth's mass. This planet is at that level and in a similar condition to Earth, so it's not only the closest exoplanet, but it also meets the basic criteria for hosting life of some kind. But we're still a long way from answering that question, and we need to perform a lot more characterization of Proxima b before we can properly put that on the table. The JWST will undoubtedly be beneficial in investigating and perhaps characterizing this planet's atmosphere. However, there is one anomaly here that JWST may be able to discover: lighting that is man-made. The issue with Proxima b is that it's tidally locked, always facing its star. These planets have a different kind of habitability than we are accustomed to. The part of the planet facing the sun would most certainly be uninhabitable, but the twilight outskirts could support liquid water and life. Depending on atmospheric and oceanic currents, the dark side of the planet may be able to maintain high enough temperatures for liquid water as well. Would intelligent life seek to light up the night side to open it up for use if it could arise or occupy such a world? If so, and given its proximity, this would be a civilization which we might immediately interact. Number 5. The solar system's oldest material. Planets are active, and the initial materials from which they were formed have become so hopelessly mixed and jumbled as a result of volcanism, bombardment, and pressure that very little old materials exists on the terrestrial planets themselves. This is not the case for all asteroids. There are meteorites that have been altered by pressure, heat, and shock, but there are also some that have not. There are things in the solar system that haven't changed much since they were initially formed. JWST is capable of studying asteroids, which is made possible by the fact that asteroids are widely spread in the solar system, and there is always something bright enough for it to examine. The asteroid CERES, in particular, remains a mystery. It's unknown where the asteroid came from. Wildcards are number 4. We live in an unusual epoch in which we can see the universe with clarity previously unimaginable. Real-time events in nature, at least from our perspective, are becoming more common, as proven by Oumuamua, Borisov, KIC 8462852, and others. This leaves little question that such occurrences, as well as even more transitory phenomena like supernovas, will become increasingly common in future years. The hardware that enables this is improving, as evidenced by the LSST Vera Rubin Observatory, which will offer practically nightly all-sky surveys exposing all manners of objects moving around in deep space. Number 3. Sagittarius A. One scary fact about our galaxy is that it contains a gigantic black hole that's devouring entire stars. Sagittarius is an astrological sign. The supermassive black hole, which is a star, is more mysterious than other black holes in other galaxies. For whatever reason, our galaxy's supermassive black hole isn't like other galaxies. Our galaxy's supermassive black hole, or rather its accretion disk, flares for some reason. This flaring, which lasts for hours, makes imaging the supermassive black hole and its surroundings challenging, which is why the first photograph, or at least reconstructed image of a black hole, occurred in the galaxy M87. This is most likely owing to transient accelerations of material to higher energies, which cause the flashes, but the mechanism behind this is unknown. So imaging it at several wavelengths is the best way to get a handle on the situation. In JWST will cover infrared. Number 2. The atmospheres of exoplanets. The atmospheres of exoplanets are still poorly understood, but what can be argued is that there are a plethora of possibilities. There are likely atmospheres similar to those found in our solar system, as well as ones that are very different from what we have here. Obviously, the most intriguing would be atmospheres that behave strangely like on Earth, where you have unusual oxygen and methane levels that are best explained by the presence of life. First stars are ranked first. Telescopes can be thought of as a type of time machine. When you look at an object in space, you see it as it once was. In other words, if you looked at anything 100 light-years away, you see it exactly as it was 100 years ago. This works across great distances of space, allowing us to perceive objects as they were just after their formation, shortly after the Big Bang. In this way, JWST should reveal incredibly early, albeit distant stars as ancient as 13.6 billion years old in a universe that's just 13.8 billion years old. These will undoubtedly be primitive stars. But what if there are surprises and components that we don't expect to see? We'll hopefully find out soon. And that's all we've got for today. Thank you for taking the time to watch the video. If you enjoyed it, please share it with your friends and subscribe to our channel to see some more great movies like this in the future. Until next time, everyone.